Okay, so the first graph, this is what I got for the first one. Although it says in the same diagram, um, I think it's the same if yeah, the y-axis is TB3 and the x-axis is time. Do you mean, is it like I have to do it x-axis with TB6, or time is fine? Because
Time is fine.
Oh,
I mean,
okay.
TB6 and TB3 on the same diagram.
Okay. Yeah,
Well, it's okay.
okay.
It's okay. It looks pretty similar.
Yes, it looks.
Yeah, okay.
And the scale of here, it's like the highest is 17 here, but the highest here is like 15.5 here.
Okay.
So there's a little bit different, just a little bit. And the second one, test each series for stationary.
Okay.
Use the unit root test, including intercept and trend. So what I got here, for the 0 legs, basically I do 0, 1, 2, 4, and 6 and 12.
Okay.
Yes, that's all I got. And the first one, it didn't pass the 5%.
10%.
Yeah, it is 10%.
Okay. All right.
So I use a black word here, and then there's a red word which passed the 5% test. And this one is 0.22, and this one is 0.04, which also passed. And this one is 0.22 again, and this one is 0.00. So, which also passed the test. And for TB6, it didn't pass for the first two, and didn't pass for these two. Well, but these two passed the 10% test. Yeah. And the last one here, 12, passed. Only this one passed the test. The rest just didn't. And the reason I showed 14 here is because I realized after 14 legs, like 15, 16, 17, it's all 0.09%. The p-value is all this one. So that's why I post another this.
So actually, we don't have to really insist on 5%.
Oh, okay.
Yeah. So if we use 10%, it seems that, they all reject the null hypothesis.
Oh yeah.
So they do have stationary.
So wait, but okay. So if we just look at 5%, then it's.
Yeah, we don't have to insist on 5% as long as it's less than 10%. I think it also this alpha significance level is allowable.
So this is stationary in this case?
Looks like.
Okay. And for TB3, 1 for 12 legs are stationary and Rula.
Yeah.
Okay. And the third one, test if two series are co-integrated. So it says regress blah. So the dependent variable will be TB6, and these are the independent variable, or the explanatory variable. And use unit root test, including here, exogenous with various legs. So I do the same. Basically, I do 0, 1, and 2, 4, 6, 12.
You mean this is what? What kind of test?
Non-exogenous.
Including okay.
Yeah.
Different version of Dickey-Fuller test.
Yes.
Yeah. Okay.
So this one more accurate. The p-value is more accurate, and here for TB3, yeah.
Okay.
And here all pass the.
All pass.
Yeah. And for TB6, it passed as well.
Yeah. Okay.
And for time, I'm not sure whether to do time or not, so I just do it?
No, we don't have to do the time,
that's fine.
since time is just a trend variable.
Because after trying the 0 and 1, after one leg, like 2, 3,
It's
4,
all-
you cannot, the result
Yeah,
cannot
it's-
be made.
It's just a trend variable. It's not the
Oh.
really the variable which we want to test for time series.
Okay.
And it time itself is a time series. Okay.
Okay. So then, and then after that, I realized there's a group unit root test.
Group unit
I
root
just-
test. What's that?
It basically,
You can do the group
yeah,
grouping.
Yeah. And the p-value here.
Okay. And what's the result of this grouping? It's all pass.
Yeah, all pass.
Okay.
Yeah, but yeah. So is model A a spurious? I think yes, because the adjust R square is high, as you can see here. Just a second. Here is 0.9959.
Well, whether. Okay, look at this.
Yeah.
If we wanted to answer whether the model is spurious or not, well, usually we don't use R square.
Oh.
Because for time series model, the high square always high,
Oh.
whether it is stationary or non-stationary, it's high
Oh, okay.
since it is time series model, so it's always high. So for answer the spurious regression is really look at, since it is model, so we look at co-integration test.
Oh, so which is the unit root test, or
The unit root test for residual. Models residual.
oh, so I should test U.
Yes, residual, isn't it? Right?
Okay.
Right? If you want to see the model is spurious or not, okay, that's why, all the procedures step by step. Okay, we test TB3 and TB6 individually, whether they're stationary or not. Okay, and it seems that if I use different version, then maybe I have different result. Therefore, if I run it as a model, okay, like model A, then I wanted to see whether this is a spurious regression.
Okay.
Then we look at the residual terms
Okay.
and test for the using the unit root test for the residuals.
So there's no meaning of testing serial correlation too?
No.
Oh, okay.
So R square is not the indicator for
Because
spurious regression.
This is what I got from the textbook. I forgot about the residual.
What
test.
is D minus 0? D equal to 0.36.
Yeah.
Okay, so this is not for the model.
Okay.
The D here is talking about the Durbin-Watson statistics.
Yes.
And Durbin-Watson statistics, just only for
Serial correlation.
lag is only 1.
Oh, okay. Yeah. That part. Okay.
Okay? So always do the co-integration test.
Okay.
Okay, go ahead.
Does the long-run equilibrium exist in Model A? Yes, because Model A is stationary due to the unit root test, which we can see all pass. Means it has a long-run equilibrium.
Because model A is stationary.
Yes.
What do you mean by that? Where you didn't do the residuals unit root test.
Oh wait, isn't the normal unit root test proof that it's
No.
stationary?
No. Co-integration test, it should be test on the residual of the model. And based on the model, then we will see that whether this model is spurious or not. Then we can answer the question for, you know, after I do the, you know, this is what we call the CEM model, right? Just error correction model for. Okay, after I do the model for the residuals, then it is co-integrate. Therefore, based on the residuals, then we can set up the ECM.
Okay.
Then ECM, I do have two regression. One is based on
The long run.
yeah, the long run.
Yeah, the one
Okay.
in
Then the other one is short run.
Okay. And okay, so here's ECM. So basically, I run an ECM on TB6 and TB3 and U minus 1 here,
Yeah.
and the coefficient here is 0.87, and is the coefficient of residual.
So
is
this is
the
the short run,
yeah,
right?
the short run.
Where's the long run?
Oh, the long run is on the top, so I did.
Okay, originally,
Yeah.
this is the long run. So, let me see the long run coefficient.
Okay. Here. This is the long run.
Okay, so which is, this is based on the TD6, so it's 95 something.
Yes.
Okay, okay.
And this one is 88. Here. 88.
Oh, yeah, okay, okay.
So by the meaning of a coefficient of ECM, when TB3 increased by 1%, TB6 will increase by this.
Mm-hmm.
In short run equilibrium, holding other variable as constant. And when the residual lag 1 increased by 1, TB6 will decrease this much, holding other variable as constant.
Okay. I mean, you know, the negative sign here means drift, you know, is the deviate.
Oh yeah, the deviation
From
between
the long run.
and short run.
So it's the deviation. Okay, so since the short run is smaller, therefore the deviation is negative. Usually the long run will be bigger, then the short run will be smaller, and the difference of that will be the deviation.
Oh yeah.
Okay,
From
although it's
long run
not,
to short run.
yeah, it's not, although it is not really using the short run minus the long run. You know, deviation doesn't mean the difference between these two. Just a drift. It's a drift.
Okay.
Okay.
And here, part C, explain the process from short run to long run, so which is the opposite.
Yeah, okay.
In long run equilibrium, TB3 increased by 1, and the TB6 will increase this. This is
Mhm.
the coefficient of the
Mhm.
long run.
Yes.
And in short run is by percentage. So here. And finally, the coefficient of this, basically residual, means 90.97% of the discrepancy between short run and long run equilibrium, just like we
Mhm.
said, suggesting a faster rate of adjustment, because it's, as you can see, it's like 20%, so which is pretty fast.
Yeah.
From my opinion.
Okay, okay.
And here, the fifth one, granular causality test.
So how many legs do you do?
I only do one leg.
Just one leg.
Oh, does it have to be multiple?
You mean several?
Yeah, several
More than
legs
one
to
legs.
test the granular causality. Because I'm not even I'm not even sure with this one. Is this one?
What is the granular causality test?
Is the test with lag 1 variable? to test if this factor will affect TB6.
Okay, look at the equation 12.20 and 21 from textbook.
Yeah, that's the one I use.
Okay, so we wanted to use y and x. So what you do is you do the difference.
Oh, I thought it's ECM, so that's why I do the difference.
No, granular causality is by looking at the original TB6 and TB.
Then what's here with
ECM? This is different subjects.
I thought this one has to come back too.
So you come back to the granular causality test in the ECM.
Yes.
No, the granular causality test means that we wanted to check what events is always precedes. It's always precedes by another event. And ECM, there's a different purpose.
So we cannot use granular causality test.
The granular causality test is for the original. Since ECM, we do have the long run model. The long run model is using original y and x.
Yes. Okay.
So the granular causality is based on the original y and x.
So basically, here we should just use model A as our
The granular causality.
model. Okay.
Although I put it at the back of, the sequence of the questions,
Okay.
but it really doesn't mean
That
that is under ECM. Even it is under ECM, I do have two models, right? One is long run model, the other one is short run model. The difference is looking at the short run.
yeah, but isn't this the short run model?
This is but granular causality is looking at the long run, means that the events always what variables always precedes by the other one. So you have to look at the original variable instead of the difference.
Okay.
That's what I'm saying.
Okay. Well then this one is.
Yeah, this is, the variable is wrong.
But I know here should be y and then.
Yeah, TB3 or TB6. We have to do the two equations.
Yeah.
One is based using TB6 as an y. The other one is using TB3 as an y. And for the rest of x, if you use TB6 as an y, you have to use TB6, the lag of the TB6, as well as the TB3, the lag of the TB3, as an x variable.
So we cannot do a granular causality test on short run equilibrium.
Yeah. Granular causality is always looking at which events precedes. So it's a long run instead of short run.
Okay. Then what's the meaning of here, the ECM?
Okay, ECM is, let's look at the relationship between the long run and short run.
Oh. Okay.
And by using co-integrating test, we can make sure although y and x are somewhat non-stationary, but the residual is stationary. And based on the information of the previous residuals, we can do the short run models.
Okay. Okay.
Then we can say that although the long run model is not spurious, then we can do the gradual causality test. Gradual causality test has to has the one of the assumption that the variables should not be non-stationary.
Okay. 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 Got it. So if it's non-stationary, then we cannot use gradual causality.
No.
Okay. Okay. So for the end here, we need to look at the f stats, right? But since my here the equation is wrong, but I have done.
Yeah.
I just didn't post it. I've done the long run equilibrium before. I know here should be like the number here. I didn't have the result printed, but the number here should be like this. So it's still yes. It's
P
still
value
yes.
for F statistics is pretty small. So means
yeah, TB6 gradual cos TB3.
okay, let's see some other students' result. You know, since you don't have a result
okay,
here.
okay, okay, yeah, sure.
Yeah. Okay.
Okay. Then yeah, that's all.
Okay. Okay.
Yes.
All right. Thank you. So who won't be the next? Who won't be the next? How about? Okay. Let's see. This one. Okay.
So good morning.
Morning.
So this is the graph for TB6 and TB3 on a single diagram.
Yeah, look at the diagram.
So as seen here or observed here, almost both of them follow a similar trend
Yeah. Okay.
going down through the values or the time
Yeah.
series.
Okay.
So I calculated the unit truth test for max lag 1 to 20, I think. Yeah, it's 1 to 20.
Okay.
So instead of giving you the table, I gave you this graph.
Okay.
So you can easily see. The y-axis here is the p-value.
Yes. Okay.
And the x-axis is the max lags.
Okay.
So based on this graph, the optimal max lag would be on 2 and 5 given a p-value score of 0.22 or 22%.
Yeah, the same result as yours, right? Okay.
So I did that also in TB6.
Mm-hmm.
So in TB6, the appropriate max lag would be 2 and followed by 10, but still
Yeah. Okay.
it's very great difference between the two. So I
Yeah.
prefer using 2 max lags with the score of 0.31 or yeah.
Okay.
0.31. Then I did that for column time, but yeah.
What is this?
It's just the time.
Oh,
I did the
okay,
unit
okay.
unit root test for time.
Okay. Okay.
But p values are all 1. So
Yeah. Obvious, right?
Similar with time 2. It's obvious.
Okay.
1.0. Then I did a test for co-integration here.
Mm-hmm.
So first, I did the normal or the usual OLS regression. R squared here is 0.996, which is pretty high. However, the test statistics here are kind of very low. So p value for f. This one. So yeah, one very suspicious or weird result here is the probability of the F statistics is 0. So I've searched for that one. So a p-value for F statistic means an extremely strong evidence against the null hypothesis, indicating significant difference between groups or a better model fit. So for now, the answer for B is yes, it is a spurious regression. So I did the.
Let me see the, what do you mean by, if you look at F test, what is that?
The probability of statistics is 0.
This is for the models.
Yes, the model.
It's for the regression model A, right?
Yes.
And this means what?
Strong evidence against the null hypothesis, Professor.
Strong indicates significant difference between groups. Now, yeah, means this model is good fit, right?
That's
Yeah, okay. Then, is model A spurious regression?
Oh yes, Professor, since these values are 0 as well. No? No.
You know, if we want to see whether this model is spurious, we need to check individual X variables to see whether they pass the unit root test or not, right? And since using different lags, then we do have different result. Really?
Yeah, I now get it.
So for individual variables, you know, maybe it is somewhat spurious. But if we want to see the model is spurious or not, we need to do the co-integration test. So did you do that?
On the latter part.
Okay, okay.
So I did the unit root test for is this unit root test? Yeah, for the residuals.
Okay.
So the only acceptable max lag or p-value with the max lag is on 20th max lag, which is on 0.06, which is still pretty low. So
Well, for what is this is the p-value, right?
yes,
The
the y-axis.
okay, and this is based on the residuals. Okay, so according to the residual, let me see the lags. The horizontal is the lags, right? So for the for first lag up to 18 is all the p-value is very small.
Very small.
So what does that mean?
It's not significant.
Means
Not significant.
means non-stationary.
Yeah.
Huh? Means what?
Non-significant.
Mean you're working with the residual, right?
Yeah.
So we're working with whether it is stationary or not, right?
Stationary.
So null hypothesis is
Not
non-stationary. Alternative is stationary. So the lag up to 18, the p-value is very small.
stationary.
So it's really pass.
Oh.
So the residual is really stationary, right?
Yes. Okay.
So it passed the co-integration test. Okay, then
Then this one is a test for co-integration. I think I did the excuse me. I did the difference here, so I used the
what is this? What is this?
the difference, Professor. I forgot to change the name here.
Then what's the y? What's the y variable?
Uh,
Run ECM? Okay,
I think TB3 is the y variable.
TB3,
Difference TB3.
this is TB what?
Difference TB6.
Difference.
I forgot to change the label, but this is the difference TB6.
So this one, you need to change it by yourself using the Python?
Yes.
Well, if we don't have, this one, what kind of variable we put in the model, then it turns out to be that.
Just the name, Professor, since I didn't change the name for TV6. But it's the difference, Professor. I just forgot to change the label or the name.
For the name, you have to change the name by yourself using
Yes.
Python.
Yes.
Oh, really? That's terrible. That is not good.
And why difference TV3, the newest residuals.
So what do you mean by run? Oh, so this is a show run.
Sure.
Both of them are the difference. Okay. Isn't this the same result as yours? It's a lot. Huh? For show run, ECM. Using delta TB6 and delta TB3. How big? Let me see. It's really small. It looks pretty. But if running a show run, what is this?
The residual.
Huh?
Residual.
But should be leg one.
Oh.
It's leg one, not the residual.
Oh, okay.
That's not correct.
I remembered wrong.
I think I give you all the ECMs. Did I? The file? Did I give you the file? What did I give you for the my material? Oh, really? All right. So not that clear the content of the ECM. Okay.
So that explains this graph, Professor. So I made the wrong inputs there. So I'll just move on to the explain the meaning of the coefficients. So I use another library here for the ECM, which yielded for the test statistics is -6.04, and p-value is very low. 0.0003. Yep, 0.0003. Then all my critical values are negative. So I'm rejecting the null hypothesis that they have. So that's cointegration. Oh, cointegration. So they have cointegration, Professor. Then this one is just an explanation. Then
Let me see your explanation. There is direct relationship between variables, the coefficient of independent. What is that?
the coefficient of the
There's nothing here.
I
The coefficient of error,
saved,
correction terms capture the long run equilibrium. What does that mean?
I saved the wrong file.
You didn't answer this question.
Yeah. Apologies, Professor. I saved the wrong file. So yeah, I did the Granger causality on TB6 to
Oh,
TB3 and then
okay.
TB3 to TB6.
Okay. So what?
These are the
what is-
results. So the p-value for the F statistics is 0.0.
So you just have like one.
Yes, Professor. Since I thought the first lag means lag 1. So I just did lag 1.
Okay.
So the p-value for F statistics is 0.07, higher than 0.05. So
Does anybody try granular causality more than one lag? Okay.
So, given that result, Professor, TB3 does not range across TB6.
Does not.
Yes, and then
Using the lag one.
yes, Professor. Then TB3 and TB6.
Yeah.
The TB6 still
Still not.
still.
And your result is, but you are based on the difference, not original TB6 and TB3. Huh?
I just used the Python language.
Yeah, they're using that. Well, what? So you're using the you write on this language,
Yeah.
then the program run.
Yes, Professor.
So usually, and I didn't see the model. I don't see model. Isn't Python give you the model
Just
for granular causality?
just output the gradient causality. The results for gradient causality. Then
There's no output. Well, that's you know, if I do granular causality, I will have using TB6 as an variables, right? So alpha 0, then I have TB 6, like 1, something like this one, okay? This is alpha 1. So if you would just use leg 1, then I do have alpha, maybe I'm using beta 1. This is I'm using gamma 1 for TB3, leg 1. So you should have this, the model. Then the other one is TB, just reverse, right? 3 and alpha 0, beta 1, which I'm using 3, leg 1. 3, leg 1, and the gamma 1 is TB6, leg 1. So I should have these two output. Then all the p-values, or
I did this. I also did the labs for TB3 and TB6 lab 1,
mm-hmm.
which is shift from or the lab for TB6, which is a shifted one or lab 1, then added in TB6.
Okay, so all of this is the output.
Yes.
So you don't have the regressions output. Oh, this
I
is,
think I could print this, but I will search for
Oh,
search for this.
okay,
But there is a model already, so I will just call the model.
okay,
Search how to get the model.
okay. All right, so you have done this one.
Ah, yes.
Well, it's hard to read the output from the Python, right? I think the information is not clear. So here, what do we have is this based on TB3, then this probability is significant. No, yeah, actually, it's this one and this one. Okay, TB6, then it is significant. It means bilateral. Those bilateral. So, is the result is this bilateral?
Yes, Professor.
But this is no bilateral. Your answer is no bilateral. Well, let me see your F. Your F is significant.
Ah,
Oh. Well, but what is this? P-value of the model is this. What is this? What is 87? P-value is 87. Where is it? What do you mean? P-value is 87.
TB3 lang. I compared the p-value for the model 6 to 3, then 3 to 6. Then if it's less than the significance level, which is 0.05, greater than. So
Well,
what you do is the coefficient. Do you have an F test?
let me
yes, F-test is there.
You see the 0.87289? You see that one?
yeah.
I mean, this one. Look at it.
What he did for this one.
I don't know where this is coming from.
This is the coefficient of the variable.
Coefficient.
Yeah,
It's not the p-value. It's the coefficient.
it's the p-value of the coefficient
A p-value of the coefficient.
of this explanatory variable. But isn't it should be f-stats? So now he's looking for f-stats.
I pasted. I forgot to paste another value there. So
Well,
Yes.
let me
this
explain this one, okay? If you just use one leg, okay? If you just use one leg, if this is 3, this is 6, right? If this one is significant, what does that mean? This one, grandeur, this one, right?
Wait, this?
Yeah. If 3, the 6, this is significant. This is grandeur, significant, this one. So this means bilateral.
Yes. So
It's not whole models.
it's not what f-stats?
If I have several legs, means values, but I have to look at, did I give you the Granger causalities material? Yeah, since I have p legs. Look at,
Oh, so if we look at px, then
okay, let me see. So this is what you have, right? Anything else?
the 0.07 should also be here since we are comparing the TB3, TB6 to the 6 TB3.
Okay, so almost,
Both are greater than 0.05.
so almost finished. Okay, let me go back to my learnings about the material, about Granger causality. I think I give it to you, right? Let me see here. This one. Oh, I didn't give it to you. Did I say? Okay, using the textbook, we do have this Granger causality test explanation using textbook, right? Okay, this one. Look at page 393, equation 1220. So did you see that YT and beta 0, then we have a whole bunch of Y legs, right? Then whole bunch of P legs.
okay.
Did you see that?
Yes, that's all.
Okay? Then test, null hypothesis that coefficient of leg A, so means the whole bunch of A. If I wanted to check the whole bunch of coefficient of A, I should use the F test. But now you're just only use one leg. Therefore, it's just the coefficient of this. Then vice versa, I'm using the original X and Y. So I put TB3 as in Y. Then I'll check whether TB6 will Granger cause 3. So I'm looking at this coefficient only.
So how am I
You mean the F test for a whole bunch of it?
Yes. So this is wrong, right? You should have a bunch of lags.
Well, if you test for one leg, that's fine too. And you can try several legs too.
Yeah, how to do this?
How to do the, yes, just add more. So like running TB3, okay.
So I cannot run infinite
Infinite legs. You don't have to do the infinite leg. Let's try 4 legs.
So if we have 4 legs, then we have 1, 2, 3, 4.
Yes, for TB6 and TB3. From leg 1 to leg 4. Do you know what I'm talking about? Yeah. Okay.
Is it like here just change to 4? Or do I have to do 1?
From -1, -2, -3, -4. Yes. Yeah. Now you have to check whether the first one, second one, fourth together. So using that, let me. Oh, okay. Using let me see. View. Okay. Then using a coefficient. Okay. Then use this either this one, wall test. Okay, then you put C1. Since I wanted to C1 equal to 0, C2, then yeah, then I don't know what separate by columns, right? Okay, then I don't know whether you can put on the same line or not. Usually I put a different line.
Yes, you can put down.
Oh, okay. Then put a 0. Negative. Okay. Then C3 and C4, since they are in the first 4. C4. Okay. Then hit OK. Well, maybe you put. Oh, yeah. There's a comma. No, you should have comma.
yeah,
You don't have the comma here.
Yeah, you should have it.
Should have the comma here. Okay, put the OK. Okay, look at the F test.
Oh.
So what do you mean by
So there's
none?
Yeah, that.
What do you mean by none? Okay, then let me see this. So maybe we don't have 4 legs, that many.
This is what I got for legs.
Well, I wanted to automatically check the F test for these 4 legs.
This one F test already?
No, this one is for whole model.
Oh.
I just want to test the part of the coefficient. You can use F test too. But how come this is no probability? Let me see the original models. Let me see the original model. This TB6 using 4, right? So all of them, you do have some probabilities here. No, actually, this is a C1, C2, C3, C4. How come there's nothing? Yeah, how come?
How
when
come I
he-
have
He
something?
he does something. So the probability is 8%, right? So if you're using 10%, then pass it.
The capital letter matters.
Yeah. How come? What's the difference? Okay, so in that case, the probability, if I use 10%, then it passed. It passed means what? Means Granger causes the TB3, Granger causes TB6. Okay, so we can do the same thing again.
So still we need to look at the F-test or
F-test, these two are really pretty similar. You can use in the F-test or chi-square, huh?
for multiple legs, like here, can can't we just look at the
No,
coefficient?
no, no. If you look at this one, this is not together.
Oh, okay.
We have to put them together.
So if it's more than one leg, then we need to look at the wall test. But if it's only one leg,
I can use the coefficient only. Okay, so if you put a 3, okay, now you test for 6. So it's from 5, 6, 7, and 8.
So you have to be manual.
Or in by manual.
By checking multiple legs.
Yeah, sure. Because the computer doesn't know. You have to do it. Tell the computers which coefficient, what coefficient together.
I thought there would be something like enter the legs and then use it.
Okay, so if it is like that, so it's all pass. So there's a bilateral Granger causes. So EView is useful. So like all of this test, after you learn it, you need like you should put all this technique in the treasure box, your own treasure box. Then in the future, if you wanted to do on the thesis, yeah, okay, then you know how to do it. Then I cannot teach you all of them, right? But what I teach, if you can use it in your thesis, then that's good. So I try to teach as many as possible, but I really cannot cover everything. Okay? So did you do that? In Python? By EViews, our result is bilateral. Bilateral Granger causes. Huh? Lag 4. Yeah, we try up to lag 4. It is? Okay, all right. But if you just use one, you can just check this coefficient only. Okay, and according to the output you have, if you use leg 1, it is the result is also bilateral. Okay? Well, it's Rachel's turn. It's possible. It's almost past times. Okay. All right. It's leave out here. This part. This is okay. You can try yours here. Oh, it's not. Oh, I have to do it.
Okay, so oh, hmm?
Look at this one.
Oh, this one.
Yeah,
Ah,
that's
okay. So, this is the plot, but I think this is wrong one. So I have another one. S- as we see on TB3 is around 16, and for TB6 is less than 16 on this plot. And for the unit root test, I'm just using. Okay. Yes, for the unit root test, including intercept and trend, I'm using leg 4, 6, and 12. This is the TB3 with leg 4 that pass, and for leg 6, it didn't pass, and for leg 12, it also passed. So I already test with like 1, 2, 3, and 4, and the result is the same as leg 4. So I'm just put the leg 4 here, and yeah, this one. When I use leg 1 until leg 4, the result is stationary. But when I use leg 6, the result is non-stationary. But however, leg 12 shows stationary, and all of these statistics have negative result. And for
So in other words, it seems that it is a suspected
station.
not stationary and non-stationary. But since we wanted to have stationary, so it is suspect variable with non-stationarity, something like this one. Okay, all right.
So is it possible if the like the various like have different result for stationary or non-stationary, like this one?
Yeah, it's really possible. So
Ah.
I think for time series model, the hardest part is how many legs do you have to choose. Usually, as long so far we don't have an answer for that. Definitely answer for that. So everybody, when we do the time series, they try so many legs. Right, okay.
And then for TB6, I also using just like 4, 6, and 12.
Mm-hmm.
For leg 4, it is pass,
Mm-hmm.
and for leg 6, it didn't pass also,
Mm-hmm.
like the TB3. And for leg 12, it obviously passed the stationary. So the same as TB3, when I use like 1 until 4, it's stationary, but when I use like 6, it's non-stationary.
Mm-hmm.
And with like 12, it's stationary. And then this is the regression model A.
Mm-hmm.
We all have the significance here,
Mm-hmm.
and this is the equations. And I'm testing the unit root test with none. And for TB6, with like 1, it didn't pass. It passed. And for like 6, it also passed. With like 12, it obviously passed.
Mm-hmm.
I'm just using like 1, 6, and 12 because when I use like 3, 2, 3, 4, 5, it I think it's the same as this one. The result is still the same, so I just put like 1 here. And for TB3, with like 1, it's obviously pass, and with like 2, it also pass. And yeah, for TB3, I using like 1, 2, 4, 6, and 12. For this one also pass. The like 6 also pass the stationary, and for like 12 also pass. So all of the leg is past the stationary weather, even though the probability is not the same. And time, Yeah, I don't have to. Yeah. Okay. And then
I'm surprised all of you do the variable of the time as a test for the stationary.
yeah, yeah. Actually, I'm not sure either. So yeah, just put it.
Okay.
Again,
No,
for
if for time series model, the t usually is a trend variable, and it's really put it in the model to detrend.
okay.
Okay, the purpose for that is to detrend. For some time series model, even you put the t, it doesn't eliminate the problem of the time series. Okay, yeah. Okay, all right.
Noted. Is model A spurious regression? At
Mhm.
first, I'm just saying that like what Steve do, that if I adjusted R square, which 0.99, which is really high, and but we check at the Durbin-Watson test and blah 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 blah. But what you just saying that we should test the co-integration
Test,
with
yeah.
U as the Y, and I got this result.
Mhm.
But I'm not sure is it correct or not.
Well, this is the U here is the model you run. This is model A's.
Yeah, yeah, yeah.
Yeah,
From
okay.
model A.
So you're what do you mean by using TB3 and TB6?
Isn't that?
What is this?
Is it? Oh, I think it's
This
this
is
one.
what is this for?
I'm not sure either.
Well, if this U is the model from is the residual for model A, means correct. Okay, using this U to do the unit root
Unit
test.
root test.
To see what if it passed the unit root test, that means reject the null hypothesis, then
it's stationary.
co-integrate
Oh.
test fulfilled. So co-integration test is to test the model's residuals. If the model's residual pass, then the whole model we don't call them spurious regression. So the difference between co-integration test and a unit root test is unit root test is two individual variables. Okay? But the co-integration test is to do the residual of the model. Although the unit root test is the same procedure, but if you base on the original individual variables, then we call unit root test. But if you base on the residual of the model, we call it co-integration test. This is what we call co-integration test,
This one.
because we wanted to see
This one
U.
or not?
We wanted to see this residual, whether the residual passed the unit root test. Null hypothesis is whether this U is null hypothesis is non-stationary. Is unit root means random walk, right?
Yeah, yeah.
Then alternative hypothesis is stationary. Co-integrate. Oh, okay. I think I need to explain it. Y and beta 0, beta 1, x. If I do individual unit root test for either y or x, this is what we call unit root test. But if we run the regression, we get the result of residuals from this model. We call it model A. So U from model A. Then unit rule test for U is what we call co-integration
Integration.
test, because the U is from the models. So co-integration test is you have to run the model in order to get residual, and based on the residual, do the unit-root test. But if we just say unit-root test, usually is by the individual X and Y.
Yeah, I know. I mean, is the result from the visit?
Yeah, this is called co-integration test because it is based on U.
Yeah,
That's why it's running U.
So, I mean, what's the meaning of probability passing the test?
Okay, this means if we're running the U test, we see these variables, U variables, okay, whether it is unit root or not. So the null hypothesis is U is non-stationary. Alternative hypothesis, U is stationary. So if you reject the null hypothesis, means U is stationary. Then if we can prove U is stationary, since U is from model A, so model A is no more spurious regression.
Oh, okay.
You know, if we run the regression, usually X and Y should be stationary. But in this case, if we say individual X, Y, either one of them is non-stationary, actually it didn't pass the assumption of the regression analysis. But you really do it, but the residuals tell us it is stationary, means that although it looks like X and Y are non-stationary, it seems that this is a spurious regression. But in the long run, there has a relationship exist in the long run because the residual passed the unit-root test. You know, actually, residual is also using the unit-root test, but the whole process is called co-integration test. Since this U is not from individual X or Y variables, but from the residual of the regressions.
So in this case, this model A is not a spurious.
Yeah, if U passed, and since U passed, right, it is reject the null hypothesis. So means the U is stationary. Therefore, this is not spurious regression.
Wow. First thinking. Okay.
Okay? I think do the assignment is more, it's important to clarify the concept of what we learn, right? Without working on the assignments, and after just have the lectures, it doesn't mean anything.
We cannot practice.
Yeah, you have to practice in order to really, understand and do, really have the good foundations for the concept, okay? Especially for individual, all the topics. Without knowing the truth of the issues, then you're unable to work on your thesis. Okay? All right? All right, go on.
Okay, thank you, Professor, for the explanation. So we have the probability here is really small, which is it's really significant, and we have the result is stationary.
Yeah.
Moreover, the model A have no spurious. Okay.
It's not spurious
yeah, it's
regression.
not spurious. Yeah, I write it wrong here.
Okay.
So and Does the long run equilibrium exist in model A? Yes, the relationships between beta 1 and y is long run equilibrium because it's stationary.
The relationship between beta x and what do you mean by
I mean, in the model y. Wait.
Yeah.
Oh, where is my?
yeah, the first one, model
Yeah,
A,
the model
right?
A.
Yeah, model A
Yeah, I mean the beta 1 here
is
is
this one. Yeah, okay. The
this
beta one
and the y is the
is the
long
TB6.
Yeah.
Okay, you're using TB6.
Yeah. This
Okay,
is the model
now,
A. And
now let's look at what you write it down, okay? And
it's a
the
long run.
relationship between
Between beta 1 and y is long run equilibrium.
no. You have to say that the beta coefficient identify the long run equilibrium for TB6
For
and
TB6.
TB3.
Okay.
Okay, and because it is stationary, no, because the residual from model A, this is called model A, right?
Yeah.
Because the residual from model A
is stationary.
is stationary.
Yeah, so it is at the long run equilibrium.
Yeah, so the
axis.
coefficient beta 1 is the long run equilibrium coefficient.
Yeah. Okay. Noted. Okay.
Okay?
Okay, so the ECM model is like this one, the delta TB6 and delta TB3 with
Yeah, so this is a short run.
yeah, this is the short run
Mhm.
and U with like 1
Yeah, this is the
and the meaning of the coefficient of ECM. The model is the correction model is negative 0.19.
almost 20%.
Yeah, that only 19.9% of the discrepancy between long-term and short-term
Yeah.
TB6 is corrected, suggesting a slow rate of adjustment of equilibrium.
Is this low or quick? Steve is saying. This one I really don't know. How big number is what we call.
How to define, is it really
Yeah, it
slow
seems
or-
that 20% looks okay. Looks okay. And like the example we have is something like just 6% or
Yeah,
something.
6.5.
Yeah, it seems it's a little bit.
really slow.
This is even 3 times, almost
Okay.
3 times.
Oh, I thought there is a standard like 30% or something that we count.
No,
Okay,
I don't know either. I don't know either because maybe we need to see the the situation. Like this one is treasury bill, so it's like interest rate, or if we use it as a non-employment rate or inflation rate or something, it's really different situation. Yeah. Yeah, looks like 20% is pretty okay. This is also my intuitive thinking, or what we say that heuristic. I don't know whether.
we go back to
Yeah,
situation.
it's really based on the economic situation. Yeah. Okay. All right. So I'm not sure whether this is, it's quick or smaller. Okay.
So, the process for from short run to long run is like this one.
So you run it again.
No, I just put it to
To
compare
the output
easily.
on it.
Yeah, just
Okay.
this is the model A, this is the ECM model.
Okay.
We saw the result above the beta 1 is equal to 0.95, this one.
Yeah. Okay. Or 96 is okay.
Yeah. And also the alpha 1 is 0.877 on
Mhm.
this one, on the
Yeah.
ECM model. And then the coefficient of delta TB3 is about 0.877, shows that a 1% increase in TB3 or TB3 like 1, which will lead average to 0.87% increase in TB6 or TB6 like 1. This
Yeah.
is the short run elasticity. The long run is given on regression model A, which about 0.95% on this one. And then the Granger causality. Okay, for this one I also
Use the short terms.
at first I used the short term, and then I'm
I'll
just
change it to
I'm just add one more to
Okay.
we can see the comparison between the short run and
Mhm.
long run. This is the long run. We have the probability here. If we use the
Oh,
10%, it
This is not significant.
but if we
So the one
If we are using TB3, means I'm working with this one, using this one, and this one is not significant from your result.
yeah.
It's not significant, right?
Yes, it's not. It's
Yeah.
not for the first
Oh, what
What we did is for the first leg.
Oh, yes. If we do this, just one leg,
yeah.
this is not significant.
Yeah, like this one we see that.
Yeah, okay.
It's
Yeah,
It's,
John also
yeah.
showed this number.
yeah, okay. That's, now I know that's what did you show?
Yeah, because what he shows, it didn't have this result, like, so we cannot.
Yeah. If we have the output, it's more clear to see whether it is a T statistics or is a p-value or
Yeah,
even F statistics or p-value or something. So I think the output from reviews is
More
quite okay.
Yeah.
Yeah, okay.
For TB3,
So if we're in TB3, then how is
it's
this one?
significant.
So 6, this one is, so using the 6 and the probability is past 10%.
Yeah. So
So it means that this
TB6
Granger
cause TB6.
yeah. Isn't
But-
that, do you have any, economics backgrounds about the treasury bill interest rate?
We know how it works, but not the
Well, usually, from this one, from the result of this one, means that the 6 months interest rate always affect the first, then it will influence the 3 months. And it is like this situation in reality. Like stock price,
Yeah, and the long term will affect.
the short term. Well, I'm not sure about that stock price, but for the interest rate, usually the longer terms, the higher interest rate. If you have 3 months, then 6 months, usually 6 months is higher than 3 months, unless you predict in the future the interest rate will go down. Okay? So usually, if you change, so for example, like nowadays, if the government want to change the interest rates, they will always set up something which is longer than all the shorter, gradually adjusted by the long terms. Okay? So in that case, this makes sense. TB6 is Granger causes TB3, but not TB3. Granger causes 6. So this makes sense in reality. Okay? But stock price, I'm not sure about it.
Kind of like the same.
Oh, really? Okay.
If we take a look at the long term, it is
we're talking about this, what we call assets, prices, volatility. In next topic is what we call arch and gauge.
But why is that with 4 legs then we will
Well, if for the,
check the length? Oh, okay.
yeah, this, if you have the longer leg, maybe, the situation is more complicated. Therefore, in that case, from our data, it seems that they change, it's really bilateral. Granular causes each other. Right? Okay. Sounds interesting, right?
Yeah, so at first I'm using the short run, but professor said it should be the long run. So at the short run, it is.
Okay, this is not.
Yeah, but in the short run, if we see the TB3 here, it is also.
What kind of test is this one?
Yeah, I think it's still the same as this one, but I'm using D on here.
Well, if we do the granular causality test, we don't have. We,
Yeah.
we don't have this term.
For-
This is not term uses in the granular causality.
Okay, so just test
Yeah.
within the
And
X, this
yeah,
one.
and do not use the difference. Just to use
Yeah,
the
yeah, yeah,
original X variable.
yeah.
So
Okay,
this
I
is
see.
not a granular
Okay.
causality test. Okay. All right.
Okay, so I'm doing it wrongly at
Okay.
first, and
Never mind.
Yeah.
We are learning from
yeah.
making mistakes.
So it's more clear, and also at first I think that we should test the F test, even though it is just one leg. But professor just confirmed that we can
Yeah, okay.
see the probability if it's just one leg, and use the F test if it have several legs.
Yeah. Since, why do we just test these parts only if I have several legs? Because this one is just the legs, explain the relationship with the legs, with the Y only. And when we say granular causality test, it should be different X variables. And the reason we set up these two is because individual Y can be itself individual X. Yeah, this is, for granular causality test. Okay?
Thank
All right.
you.
All right. Thank you. Okay. Then let's stop here. There's only 15 minutes left.
There's still time.
Well, let me see whether this one I'm sorry, this is the data. Is this the data I'm going to use today? Let me see. Let me see. Look at this data set. This the data set.
No, that's not.
Oh, it's not. There's different. So which variable I'm using this one? Okay, I think I'm using different data. Let me see. Let me see my data set. Maybe it's just. Oh, I'm using this one. I'm using LNEX. Okay. So this is not the data set. Let me explain one thing. do I have all this data set? I thought I put it in. Let me see. Oh, maybe I'll get it from this one. Not finishing. Oh. Okay, let me explain something from my Blackboard first. Okay, let's use foreign exchange rate. Foreign exchange rate. Okay, let me explain it. The data I'm going to use is the foreign exchange rate from the ECU to US dollars. Do you have any, I mean the euro dollar currency, currency, okay? Do you familiar with those exchange rate?
Yes, euro with USD. I think euro is, I'm not sure with euro, I know USD is
ECU, usually we use ECU. Well, let me say in this way. Usually, international foreign exchange rate usually is based on US dollars as a base. Okay, so like ECU is euro dollar currencies. At the beginning of the ECU, if you look at I think you can check with the history of the ECU. Is any?
during the pandemic and this.
No. You have to. I mean the exchange rate. I mean the dollar values. It's not just the diagram. Any histories? Okay, nowadays is 1.07, 1.08446. So I mean the histories. Histories. Do you have the histories? I just want to say some, give me some numbers, that'll be fine. So, okay, this is one. The first, now is 446 or something, right? So anything. 1.04, okay, I think that's enough too. 1.18, 1.18. This is 23 up to now. It's 1.08, and this is 2020 and 2021. Okay, so just see this as an example. Okay, just see this as an example. This is foreign exchange rate, ECU. Okay, and usually, what's the rate of return? What's the rate of return? If you're talking about rate of return, how do you see the rate of return?
1 over this.
Since this one from this one, this one from this one, right? So usually is using 1.05 if minus 1.18 divided by 1.18 is the rate of return. This is the idea of rate of return. Would you please calculate for me what's the rate of return? This should be negative, right? And count as another one is this. Well, you can see this one is something like this one. minus 1. Okay? So this is 0 point what? Negative 11, okay? So should be like this. Negative 11. Okay? And what is this? This 1 point what? Minus 1. You know what I'm talking about? I'm talking about the currency, foreign currency exchange rate for ECU, and which against US dollars. So nowadays it's like 108. Means if you have one ECU, $1 for ECU, you can get 1.08 US dollars. Yeah. This is what we mean by 1.08. Okay, so ECU is bigger than US dollars. So like Taiwan against US dollars, what's that?
Taiwan against US dollar is 13.8.
We need to use this one. Nowadays it's 31 something 8. Maybe. 30.8. Okay. It's not 31? Are you sure? Okay. So look at this one. It should be 0.03 something. So look at this. So Taiwan dollars is very small. Again. Okay? All right? So look at this one. What is this? So it's 1.0. So maybe 1.03. So like 3%. Maybe. It's around 50. So it's like this one. It's a 0.03. So this one, if you invest ECU last year, up to now, the annual rate will be 3%. Okay, this is what we mean. And if you buy US ECU 2 years ago and you keep it up to last year, then you lost 11%. So this is what we call rate of return. Okay? But it's hard just by look at this one. We need to do the calculation, something like this one, in order to know the rate of return. Okay? But if you take the log, natural log of each one of them, so would you please using the Excel to calculate the log of ECU? LN, natural log. So I'll say natural log ECU. So 1.08 equivalent 0.07. Okay, make more 4 decimal places. 69. 0.0769. Then how about 1.05? 0.0487. Then how about 1.18? 1655. Okay? And look at the difference of this. Difference. So using this one minus this one, what's the number? And this one minus this one. What's the difference? So the difference of natural log ECU. This is 0.0282, right? And this is 0.11, huh? 68. Am I right? 78. Okay. 7. 487 Yeah, that's right. Okay, look at this one. Look at this one. You know, this is, I really, put only 2 decimal places here. So this is similar like 3%, and this is like negative 11%. So usually, if I use the natural log of the original ECU, then the difference will be the rate of return.
Is that what we all do on the used to?
Yes. So we will use this original foreign exchange rate, then make it as a natural log. Then do the difference, which means we study the rate of return of the currencies. Okay, so I'll give you the data set, which I'm going to use for assets and assets price volatility issues. Okay, then you can see that the data, which they have the original foreign currencies and also the log of the foreign currencies. And usually all the analysis is based on the log of currencies. Okay, that's the reason. Okay, so this, and if we study the difference, which is the rate of return, the variables we wanted to see. Okay, all right. So I think next week I'm just going to cover all the lectures. Okay, then I'll just read the reports from Dylan and Jay. Okay, no presentation for the next several weeks. Okay, I'll more focus on the material, which I don't think we have enough time for the presentation. And I hope that we have some forecasting for all of you. Although we don't really have much time on that, but I still want to cover that too. Okay? Well, let's just stop here today. All right? And I hope they all can hear what I wanted to say next week about the assets price volatilities. Okay. Okay, thank you all. Well, I think we do have a long